Hello all, this is Andy here. This is one of the multiple videos discussing Cisco Meraki. Here I am gonna show Meraki SD-WAN configuration. How to do the SD-WAN configuration if you have multiple links connecting to your core router or directly to the Meraki device. So I have a demo firewall here which is live. However, I don't have the two WAN connection directly connecting to the Meraki box. As of now, I have only WAN 1 enable. If you see this WAN 2, it says not connected. But however, I can show you how to do the traffic shaping, what all options we have in SD-WAN to configure. Okay, so let's assume I have WAN 1 connection connected to one of the internet circuit and WAN 2 connection connected to the other internet circuit, or else it can be your MPLS as well. So there are different deployment methods. You can go to the Cisco Meraki SD-WAN documentation, where you can see how the SD-WAN device can be configured. It can be directly circuits connecting to your Meraki device, or it can be the one arm setup. Okay, so you can go through this documentation. It's a very good documentation which shows the high level topology and the possible deployment of the Meraki SD-WAN. So we assume a simple method where we have two circuits directly connecting to a Meraki device. One is on WAN 1 and the other one on WAN 2. So once these links are up, you need to go to the security and SD-WAN. Go to the SD-WAN and traffic shaping. So in this you have multiple options. We will go one by one. So starting we have uplink configuration. So this is the it shows WAN 1 500 Mbps and the WAN 2 500 Mbps. So the maximum available throughput is what is the maximum available throughput for this device. So it depends on the what model you are using. So based on the throughput, it will give an option you to select the starting from 0 to the maximum available rate. So in this case it is 500 Mbps. So you need to define the values here, saying that let's say like WAN 1 is the primary circuit and WAN 2 is the secondary circuit. So you have more reliability on WAN 1. So we will keep the traffic priority to the WAN 1, and we will also use WAN 2, but there will be two cases, like if the WAN 1 goes down, your entire traffic should go to the WAN 2. However, based on the you can do active kind of, some of the traffic goes to WAN 1 and the WAN 2 some of the traffic. So in you can do a load balancing kind of the traffic shaping as well. So yeah, I'm assuming my WAN 1 link is more reliable, and it has a good SLA. So I'm keeping WAN 1 as a 500 Mbps, and WAN 2 I'm making it as, let's say, 100 Mbps. Okay. So we don't have cellular network here, so just ignore this one. And for the uplink statistics, you can anyways, like for example, this SD-WAN box needs to be monitor whether which uplink is up, and if in case it goes down, how it will come to know. So you just need to write one rule here. So there is one rule already saying that you keep on checking the internet connectivity by pinging this IP. So what he will do is he will continuously ping this IP, and if he's receiving the response from the Google on this IP, so he will assume this circuit is up. Okay. So you can add one more, or else you can add any of your any other specific IP of your own public IP. Okay, so that also you can do. Yeah. But the best is okay, whatever is best you can make it as a default. Okay. Now the uplink selection. So this is the global preference where you will give which uplink is best suited for your traffic. So let's say yeah. So for in our case, the WAN one is the more reliable one. So we will select WAN one. And okay, you need to yeah, as I said, like if you want to do a load balancing, you just need to enable this. So the traffic will be separated across both uplinks based on the portion specified above. So based on the portion, he will do the load balancing, and the management traffic will by default use the primary link. Okay, so the primary link is whichever you are selecting here, because the management traffic is always so what management here, management in the sense like we are using cloud dashboard to configure the Meraki, right? So all this cloud dashboard and the firmware upgrade, whatever configuration is getting pushed from the cloud to the Meraki devices, it will use the more uh, priority link. So you can disable as well. Okay, that based on the so as of now, just ignore this one. This is the auto VPN kind of deployment. You can go through the documentation. So we are not keep it as a enable. Now the flow preference. For example, if any of the traffic, okay, you want this specific link to be chosen for that traffic flow, you can do it here. So let me add one use case. So let's say you have uh, some of the servers in Azure cloud. Okay, so let's say you have some servers in on public cloud, and this is the public cloud IP given to you, uh, starting from 0/24. Okay, let's take /29. /24 is a big pool. Okay, so yeah, you want to allow HTTP traffic to this source, and the destination to your network, make it any. Okay, and you want to allow 443, so allow 443, and what preferred link you want for this flow. So I'm selecting WAN 1. Okay, let's say I have Azure cloud as well. Okay, yep, I'm assuming this is the public IP of the Azure cloud, and I want to allow say TCP, and we want to allow SSH here, or else any specific port, customized port, let's say 5555, and I want to allow to all my public segment on the same. So I want to select the WAN 2 link for this kind of traffic flow, because it's based on your decision, and you need to talk to the server guys and find out what is the priority for you. So let's say if most of the Azure traffic I'm sending on one WAN 1, so most of the time this will be utilized. So I don't have much traffic flow on WAN 2, so I want to make this traffic coming choosing the preferred link as a WAN 2. So in this way you can add a preference to your internet traffic. And yep, so let's create some SD-WAN policies for the VPN and the SaaS applications. So the very cool, the good feature about the SD-WAN. It is application aware. Okay, so it knows what application needs what kind of the SLA, and which application needs to be given a priority in the traffic flow. So those kind of rules you can write here. So I already have some of the rules here. Let me delete. Okay, yeah, I want to add a rule for my voice traffic. Okay, yeah, before that okay, yeah, let's use the inbuilt values. Let's say video and music. So all video and all music. So it's an so all the applications are already inbuilt. So most of the SD-WAN boxes has more than 2000 plus application awareness, uh, where you don't need to mention specific values for or you don't need to create SLA for those applications. It is all already inbuilt. So you just need to select it. So let's select video and all video and music, because all the video traffic is important for our office, assuming that we are into the video domain. Let's say if email, that is again important. So in the email you can see it has all Windows, Gmail. So all if you select the all email, it will cover everything. And okay, what I will do, let's create a separate rule for video and the separate rule for the application. So yep, so I'm creating a video, a selected video. What is the preferred one? So here for video you want to do load balance, you can select the load balance. Okay, and if you want the WAN 1 should be the preferred one, so obviously WAN 1 is the preferred for us. Okay, because that is the more we are making it as a primary. Failure if the if let's say if there is a poor performance for the video traffic and the music, so what link should it it should do a failover. So on what basis? If the uplink is down, so the if you select the uplink is down, it will do a failover only in case of uplink down. But in this case, we will choose poor performance. So if the WAN 1 link is, if there is congestion, if there is poor performance on the WAN 1 link, it will automatically switch the traffic to the secondary. Okay, so again once it sees that the performance on the WAN 1 is good, it will do a rollback. Okay, so you don't need to worry about that. And we will select the predefined performance class. So performance class is nothing but on what SLA the SD-WAN fabric should decide that this link is performing poor. So you can define your own custom values. We will in another rule we will define our own custom values. So as of now I am selecting the predefined one. So that is the VoIP. Okay, that's all. So now all the video traffic in your network, once it comes to the this reaches to the SD-WAN box, what he will do, he will identify this is the video and this is the audio. So I need to send it to the WAN 1. Okay. So the beauty about this policies is you need not to tell the box that this is the subnet belongs to the video, this is the subnet belongs to the audio. So that thing is not happening here. So in the traditional method where our core routers, okay, were not aware of the application layer visibility. So we used to do a traffic shaping based on the subnets. So let's say the 10 dot subnet belongs to the voice, 192 subnet belongs to the data. So based on the subnets we used to do some policy based routing. So, but however, in the SD-WAN, that is the main feature of SD-WAN, which has an application awareness, which has an application visibility, how the application requires the performance. So based on that, it will do the traffic shaping for you. So let's create some custom values for us. Let's say I have an application. Let's say we have an internal application. It's an, we can say like application. Let's say XYZ. You have an XYZ internal application, and you know the what is the values and what is the best values required for your application to run on the internet. Let's say you need the maximum latency of around 5. Let's say the application is uh, a video conferencing application. So you don't need the latency is 10 is the optimal, that is okay for the video traffic, and you need very less jitter, and the loss, you cannot afford any loss in this traffic, so let's say 0. Let's create one more application. Let's say application XYZ. It's an data traffic. Let's say data. Okay. And in this, you can allow the latency up to 30 milliseconds, and jitter can be up to 10, because so normally the data is on a TCP base, so it's okay. I mean, even if there is congestion, the TCP can do I mean, if there is any loss or something, congestion or something, it can initiate the session once again. And the loss is allowed around, let's say 5% loss. Okay. So in short, for all the applications which are not inbuilt, which are not popularly known on the internet, you need to create such kind of SLAs. Okay. Let's say I will create one more application. Let's say we have an voice conferencing application. So in that also you need same. In this, jitter is 5 and loss can be allowed for 2%. Okay, that's okay. So I will add the rule. Custom expressions. So you can so you know like from which data center that traffic is coming from. So let's say 50-50, let's say 20-20-20 0/24, and this is traffic coming on port number 5555 coming to any. Add an expression. Now here you need to select WAN 1, poor performance, on what SLA. Okay, it doesn't shows. I think I need to do a save. So yep, I have rectified the values. So I have one application which has video traffic and one application which has data traffic. So in the video traffic, we cannot afford any loss. The jitter can be up to 5. Okay, and the latency can be up to 20 milliseconds. Whereas in let's make it 10, because 20 is more for video. So in case of data, I can afford the latency up to 20 milliseconds. So it based on the application. So you need to check with the application team what exact uh, how uh, what we can say how much congestion is allowed for their application. So if there is any more congestion on the application, so it depends on the over the period of time you need to define these values. But in case of data, it is always TCP, so you no need to worry about the uh, the much difference in the values. So based on the over the period of time you can improve these values. Okay, so I have created this. Let me do changes. Okay, so these two the SLAs are created, custom preference classes. Now I will bind this to the specific traffic. Let's see. Add an expression. So any traffic coming from this public IP to your network, preferred link will be WAN 1. Failover on the basis of poor performance. And so what is the poor performance here? So you need to select the class video. That's it. So you can see this rule is added. So whenever this application, your own applications which are not available over the internet and which are not known to the predefined classes, so you can create your own class. Now, okay. Yeah, this is global bandwidth limits. Speed burst allows user to temporarily exceed the bandwidth limit for up to 5 seconds and still keeping them under the bandwidth limit over time. This option provides a better experience to the user browsing the web while not slowing down the network if they are transferring large amount of data. So it's kind of speed burst to the users if he is trying to access any the internet traffic which requires more the bandwidth, so he will be given that speed for 5 seconds so that there should be no disruption. So this is a good feature, you can enable it. Now the one more traffic shaping you can do here. So this traffic policies what we created is for our VPN traffic. Let's say you have the VPN between the multiple data centers. Let's say as we saw in this diagram, right? So let's say you have multiple data centers into different locations, and in this SD-WAN fabric you have any VPN connectivity. So in that VPN traffic flow, these policies will be uh, uh, enabled. Okay, so this policies will come in picture when it is a VPN traffic. So let's do the traffic shaping for the applications, the SaaS applications. Okay, so let's say I'm enabling this default rule for so there is a default rule for the voice and other website like software updates, online backups and all. So this is using the predefined DSCP tag. So if you know the DSCP tag, which are the quality of service predefined tag, so based on those values, so we already have default rules created, but if you want you can create your own custom rules as well. So let's say add a new rule. Let's say video and sports. Let's say uh, your office need the access to these port channels. So based on uh, the project requirement, so you can enable this one. Let's select add sports, all sports. It doesn't. y- Yep, I'm not sure why it's not allowing this one. Yep, there you go. So all sports, and you need to uh, if you want to do any bandwidth limit, choose a limit. Ignore network per limit. So this is unlimited. Okay, so the client will get whatever bandwidth he wants. Priority for this traffic is high, and the DHCP tag. So let's select high throughput, latency insensitive. There should be an multimedia streaming. Yep, high. Okay. So you can select the predefined DHCP tag. Yes. Okay. That's all. Just save it. That's all. So for any the sports related traffic, it will be given a high priority here. So the priority is again based on this uplink selection. And caching, you can ignore this one. So save changes. That's all, guys. So based on this, the VPN policies, and based on your traffic shaping for the internet traffic, so based on this, your SD-WAN will forward the traffic to the internet in between the WAN and WAN 2. Yep, that's all in this video. Thanks a lot.